Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 30 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 763, partition labels. Let's read the problem statement first. You are given a string S. We want to partition the string into as many parts as possible so that each letter appears in at most one part. Okay, so for example, the string ABA-BCC can be partitioned into ABAB and CC. Okay, so here if you see in this group we have letters A and B. Okay, and if you see this group, in this group we don't have A and B. Okay, same way in this group we have C. So if you see the first group, in this group we don't have C. Okay, so A and B both are appearing in one group only. Okay, so if in one group I am using AB, then this AB should not appear in any other group, right? So see here, but partitions such as ABA, BCC. Okay, so here in this group B have B, then by B is here in this group. Okay, same way, if you see this example, in this group I have A, why A is here then? Okay, if I have B here, why B is here in this other group? Okay, so these are invalid. Okay, so we want to partition the string into as many parts as possible so that each letter appears in at most one part. Okay, here see, note that the partition is done so that after concatenating all the parts in order, the resultant string should be S, and in the end we have to return a list of integers representing the size of these parts. Okay, so let's suppose if I have string like this A B C D. Okay, this is my string. So for this string I can partition like this now, A, okay, and here B, and in other we can return C, and here in other group I can return D. Okay, so this is the best case, right? I want to partition the string into as many parts as possible. Okay, so here all the characters are unique, so I can form total 4 now. So in the output I don't need to return these characters. Okay, what I need to return, I need to return the size of all this. So here just one, for B one character only, one. So this is going to be the output for this particular string. Okay, done. All right, and but same way, let's suppose if I have string like this A and C, then I have to partition it like this ABA. Okay, and here I have to use C. Okay, I can't use this like A and then B then A. Okay, so for A two groups are there. Okay, A is in two groups, so that is not valid. Okay, so for this my output is going to be here for this ABA 3 side and for C 1 side. Okay, that's it, this is my output. All right, so now see this example number 1. Okay, so here what how we are partitioning A until here we are taking one string, right? Okay, and this string length is 9, that's what we are writing, and then next one is starting from this D and until where it is, until this E, right? Until this E it is there, right? So after that next here its length is 7, length is 9 for this one, and if you see the end which is starting from H, for this one length is 8. Okay, so this is what we are actually returning, right? 9, 7 and 8. So here pick any group. Okay, so pick any group here. From here let's suppose you are picking this group, this middle one. Okay, until D to E. Okay, so see, D is here now, so you will not find D in any other group. E is here, so you will not find E in any other group. F is here, so you will not find F in any other group. Okay, you will not find, then G will you will not find. Okay, so all the characters which are there in group 2, they are not there in group 1 and 3. Okay, so the partition is like this and this. Okay, so this is a partition so that each letter appears in at most one part. Okay, a partition like this and this is incorrect because it splits as into less parts. Okay, so we don't want to split our string in less parts. Okay, so here uh, for this particular example you can say that this is also valid, but no, we want to split in as many parts as possible, right? So that's why this is the best output. Okay, so this is what we are doing here. Okay, so I hope that you guys are clear with how we are getting the output. Okay, and now let's understand how we are going to solve this problem using this particular example. Okay, All right, so this is a string given to us. Okay, so in this string, if you see blue color, okay, we are partitioning like this. Okay, Bob, then H, then A, then S, then here P E double P E and R. Okay, so this is how we are partitioning. Okay, so B O B, okay, you will not find B and O anywhere in any other group. H, you will not find H anywhere. A, you will not find in any other group. S, you will not find S in any other group. P and E, okay, P and E, you will not find that in any other group. R, you will not find in any other group. Okay, so many groups are there, right, for this particular thing. So Bob has pepper. Okay, so here how this is how I'm returning the output. Okay, for this length is 3. Okay, then 1 1 1. Okay, and then 5 and 1. Okay, this is how we are returning output, and this is just a visualization of this. Okay, now how we are going to solve this. Okay, so that's important. So what I'm going to do here, first of all, we have B. Okay, so I will just write the last index. Okay, last index. So b is occurring last time at index 2. Okay, at index 2 B is occurring last time. Okay, so here I will store the last time where this particular character is occurring. Okay, O is occurring last time at 1 only. Okay, so O, I am writing 1. Okay, then H is occurring for the last time at 3 only. Okay, so H I'm writing at 3. Okay, then A is occurring last time at 4. Okay, so here I'm writing A is occurring last time at 4. Okay, and then S is occurring for the last time at 5. Okay, S is occurring for the last time at 5. And then P is occurring for the last time at 9. Okay, P is occurring for the last time at 9. Okay, and then E is occurring for the last time at 10. Okay, E is occurring for the last time for the at 10, and then R is occurring for the last time at 11. Okay, so here this is nothing but I'm going to create one array. Okay, last occurrence array, let's say, and since we have only lowercase English letters, right, lowercase English letters, so we are good. So right, we have only 26 lowercase English letters, so from 0 index to 25 index. Okay, 0 is showing A and 25 is showing Z, right? So in that last occurrence array, I will just store the last occurrence of all the characters. Okay, so here this is what I have to do. Okay, so last occurrence of B is at 2. Okay, so I will just store that. So this is nothing but indexes. Okay, indexing index. Okay, this is nothing but index. Okay, this side index I writing, and this side I'm writing that particular character. Okay, so this is done. Okay, so you can here in array I have to represent A is at 0 index now. Okay, so if I create one array of 25 size, okay, so at 0 index simply means A, at 1 index we have B, okay, at 2 index we have C, okay, and so on until Z we have to do. So Z is at 25. Okay, so that simply means that this B I can store this value in last occurrence of 1. Okay, at 1 index we have B now. Same way for O, there will be some index, okay, inside this, like this A. So A, for A I have to store that in 0 index. Okay, A is at 0 index now, so that's simply what we have to do, right? Clear? So first thing is just calculate the store the last index of each character in string s. That's the first step. All right, then after storing that, now you have to iterate over this string one by one, starting from this index. Okay, so starting from this index, so here what you will check. So initially create two variables. Okay, one is partition start. Okay, and uh, start from 0. Okay, and partition end, and just assign value 0 here in the starting. Okay, then you have to start iterating from this particular index, and since we have to return the answer in this format, okay, in the list of integers, so create one list of integer partition sizes. Okay, so in that particular list I will just store the value. So let's suppose this is the list where I want to store the values. Okay, one by one. Okay, this is empty right now. All right, so now here I'm going to start from here, B. So B, first character is B. So for this B, what is the, I have to find the partition end. So for this B, okay, for this B, first character is this B. For this B, what is the partition end? Okay, so how I will check that. So I will take into consideration where was the last occurrence of this b. So last occurrence of b was at 2. Okay, so I will just update my partition and to 2. Okay, I will update it to 2. Okay, right now done. Okay, and right now my I is at 0 index, and my partition end is at 2. Okay, partition end is 2, so I'm not going to do anything. Okay, now I'm going to move my I forward, so my I reaches here. Okay, 4o. Okay, 4o, the partition end is at 1. Okay, right, 4o, the partition end is at 1, but here my partition end value is 2, which is greater than this o, right, this is greater than 1. Okay, and why my partition end value is greater than 2? Because of this b, because I'm starting from here now. Right now I am starting from here. Okay, so partition end I have to always update the max. Okay, so here I will update my partition end only, okay, as math.max of partition end. Okay, okay, but whatever the partition end value, okay, initially. And now here the last occurrence of that particular character. Okay, last occurrence of that particular character, let's say I. Okay, so here partition end previously for this b is 2 now, and here I'm getting the 1. Okay, so I don't need to update. Okay, I will keep it as 2 only. So partition end I will keep it as 2. Okay, next time again I is at 1 and my partition end is at 2, so I'm not going to do anything. Then my I is going to move forward. Okay, so now my I is at index 2, and for b the last occurrence is at 2, so here 2 again 2, so it will remain 2 only, and this time my I is matching with the partition end value, which is 2. Okay, so in that case what I have to do, in the my partition size array list, I will add what? I will add this size. Okay, this size. So how I'm going to calculate this size? So right now my I is at index 2. Okay, I in that where from where I'm starting from this position. Okay, so partition start value is 0, so 2 minus 0, and here just add 1. Okay, so I will get 3. Okay, so 3 is what I need to add here. And then for the next time my partition start is going to start from here only, right? So now I will update my partition start as the I value, current I value is at 2, so 2 plus 1 3, so my partition start is going to become 3 here. Done. Okay, this is done. Right now after that again you have to start from here now. Okay, so now my I reaches here. Okay, so at I is equal to 3. Okay, so first of all, what is the last occurrence of h? Okay, last occurrence of h is 3, so here I will add 3. Okay, and partition end from the last time, it is nothing but 2. Okay, so now out of these two, what is max is 3, so I will update my partition end to 3. Okay, this is done. Partition end is updated to 3, and now I will check. So right now my I is at 3 and partition end is also at 3, so that simply means that this is one more valid string. Okay, this is one more valid partition. Okay, so what I have to do, I have to add this size. So how we are going to add this size? So 3 minus here na 3, and the partition start from this time is 3 plus 1, so I will get 3 minus 3 0 plus 1 1 only. So here I will add 1, and for the next time my partition start is going to update I plus 1, that simply means at 4. Okay, so here I will update partition start to 4. Okay, so I have added 3 and 1. Okay, now again next time again my I is going to move here. Okay, and then I have to update the partition end. Okay, so partition end will become 4 now. Okay, partition end will become 4, and my I is also at 4, so I have to add one size here, and next time my partition start is going to start from 5. Okay, so this is how you are going to feel. Okay, so this is done. Then same way for s you have to do. Okay, so my I is going to add 5. Okay, my partition end is going to update to 5, my I is at 5, so you have to add this size, and then next time my partition start is going to be at 6. Okay, so for this 6. Okay, so now my I reaches here. All right. Okay, so now see here my I reaches here, and I have updated till here till 311. Okay, until here I'm done. Okay, until these 4 values I have filled. All right, now here uh, my I is at this. Okay, so again for p partition end from the previous time it was at 5. Okay, so here this value is 5, and here the last occurrence of this p is at 9. So 5 and 9, but is max we have to update partition end, it is going to be 9. Okay, so I am updating it to 9. Okay, partition up and becomes 9. Then here I is equal to 9. Okay, no, partition end is here na, no. The next time my I is going to move forward. So E, for E, partition end from last time is 9, and this time E's last occurrence is 10, so my partition end is going to become 10 now. Okay, bigger value we have to write now here. So this is done. So here my partition end is going to become 10. Okay, then again my I is not equal to this here. Okay, partition end is here now. So again I is going to move forward. Then again my I is going to move forward. Okay, it will check this. Okay, still it is going to remain 10 only. Then my I is reaching here. Okay, now I is going to become equal to partition end. So in that case you have to calculate the size. So how you're going to calculate the size? So 10 minus p start is 6 plus 1, so that is nothing but 5. So you have to add this 5 here, and the next for the next time partition start is going to be I plus 1, that is nothing but 11 here. Okay, this is going to become 11, and now this is done. The next time you are again going to start for this one. Okay, so for this one partition end is going to become 11. Okay, if partition end is 11 and your index is also 11, so you have to add this particular value. Okay, size here 1, and then for next time your partition start is going to become 12. Okay, and now this time you have to stop. You have covered all the elements in the list. Okay, in this particular string you have covered all the elements. Okay, you go out of mount, so you have to stop. So in the end you have to just return this. Okay, so that's what we need to do. That's it. Now let's write the code. Code is very simple, only few lines of code. Okay, it's not big code like yesterday. Okay, so yesterday actually I think I made a 1 hour video. Okay, yesterday problem there was a lot of code in that. Okay, and a lot of new concepts, right? So I hope that you have practiced that question as well. So here first create the array. Okay, last occurrence. Okay, I will store that new int 26. Okay, then you have to just iterate over the elements. Okay, for here you can do one thing. uh, you have to store the index. Okay, the last time where it occurs. So for that run this loop. Int I is equal to 0, I is less than s dot char s dot length. Okay, and here I plus plus, and then after that here you have to update now last occurrence. Okay, and here s dot char at index I, whatever the value that we have. Okay, in this I'm subtracting a, so that I will get the particular index, and at that particular index of that of my last occurrence array I have to store the I. Okay, I is nothing but the last occurrence. All right, this is done. Okay, then you have to create two variables. One is partition end, so let's say a p is a partition end, set it to 0, and partition start you can set it to 0 as well. And then you have to iterate over all the characters in string. Okay, int I is equal to 0, I is less than s dot length I plus plus. Okay, and here inside this you have to update your partition end as math dot max of partition end, and here you have to store the last occurrence of this particular. Okay, so last occurrence. Okay, and here inside this you have to pass s dot char at index I minus a. Okay, so that will get the frequency. Okay, at that particular index. Okay, so this is done. This is how we have to update the partition end. And then I told you that if my I becomes equal to partition end, then in that case only in the partition size array. Okay, partition size list. Okay, so we have to return the list now, array list. So here do one thing, create that, right, list of integer. All right, and here partition size. Okay, so here you can say answer. Okay, in the answer I will operate. Okay, answer is equal to new array list. All right, this is done. And here you have to update what? You have to update your array list now, answer. Okay, in this answer dot add you have to add the particular size. Okay, so how we are calculating the size? I minus this start. Okay, partition start. In this I was adding 1 to it. Okay, so this is how we are adding the size. Okay, and then next time my partition start is going to update to the I plus 1. All right, and in the end you have to just return the partition size. That's it, return partition size. Okay, this you have to return the answer, right? Answer, that's it. Now let's run the code and see if the code issue will try to fix that. So yes, so here this is a string, na? So you have to write like this s dot length. Okay, let's run it again. Okay, so here this spelling mistake, add t here. Let's run it again. So the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be of n only. Okay. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.